Okay, we are going to begin by looking at Unit 3 transformations. We're talking about what a transformation is. We're going to be dealing with lots of different types of transformations during this unit, but we're just going to start with the basic information. We're talking about something that's changing position, shape, or size of a figure when we're talking about a transformation. The pre-image is the original image. For instance, if I have point right here, and I move this point to this spot, we label it like that. This is the pre-image. This is the image, my new image, where its new location is. And I'll let you read that on your own, just kind of highlighting a few things here. We have notation that's used to identify, to show our movement. If I have x, y, and I'm saying that I have a transformation, and my transformation, basically I take my x and I add 2 to it, I take my y and I subtract 3 from it. You know, that would be an example. Well, what kind of movement would I have if I were to do that? The plus 2 means I would be going to the right 2 places. The minus 3 of the y, since the y-axis is up and down, would say I would be moving down 3 places. And we'll look a little bit further at that in a few minutes. Rigid motion, or isometry. What we're talking about here is it's transformation that changes the position of the figure, but it does not change the size or the shape of the figure. Again, we'll get into this a little bit in more depth. So let's look at this. We have triangle ABC. The pre-image is right here. Our image is right here. Is this or is it not rigid motion? Remember, rigid motion does not change the size or shape. Well, what we've done here is all we've done is rotated this triangle. It still is the same size, it still is the same shape, therefore it is a rigid motion because there was no change in size or shape. Now look at my next one here. I have triangle ABC and I've moved it to this next shape. This is not rigid motion because what I've done is I've stretched it out. It's longer. I have changed the shape of this figure. I've not just moved it around, I've actually changed the shape. And see here, I have a smaller triangle in this pre-image. My image is larger. That means it is not rigid motion because I changed the size of the shape. It's the same shape, just blown up a little bit larger. Okay, next we're going to look at a couple of formations. We're going to use the coordinates. We're going to plot the images of the vertices, and then we're going to connect the dots and see if it has rigid motion or not. So let's look at this one. I have x minus 4, which means I'm going to go to the left 4, and then y plus 3, which means I'm going to go up 3. Now we could do it that way, or I could find the coordinates of my triangle. For instance, this is 0, 4. We have 0, 0 here, and we have 2, 0 here. And I could say 0, 4, I'm going to subtract 4 from my x, and I'm going to add 3 to my y, which gives me a new coordinate of negative 4, 7. Negative 4, 7 is right here. Now if I had done it this way, where I counted 4 units to the left, 3 units up, 1, 2, 3 units to the left, or 4 units to the left, 3 units up, would still get me to that same spot. 0, 0, subtract 4 from my x, add 3 to my y, I end up with negative 4, 3. So negative 4, 3 would be right here. And then my last one, I have 2, 0, subtract 4 from my x, add 3 to my y, negative 2, 3, which would be right here. Now there is my new triangle. I have transformed it to this spot. Is it or is it not rigid motion? It is rigid motion because I haven't changed the shape at all. I've just moved it over. Okay, let's look at B. Okay, so my shapes are, my vertices are still the same. I've got 0, 4, 2, 0, and 0, 0. What I'm doing now is I'm taking my x and I'm changing the sign and I'm leaving the y the same. So 0, 4. Okay, I paused this, so if I'm repeating something, I'm sorry, but it's been a few minutes since I was doing this. So here we have a transformation, and we're going to start with 0, 4, and we make the x negative, and the y stays the same. So that means 0 is we can't make 0 negative. 0 is not positive or negative, and the y stays the same. So 0, 4 is my new point, and it's actually the same point. So let's do that with 0, 0. We make the x negative, which again 0 should stay the same, and the y stays the same. So that point stays the same. Then we get 2, 0. Well, we make the x negative, so that positive 2 is going to become negative 2, and our y stays the same, so that's 0. So if I plot that point, I end up with this triangle. Is this the same shape and size as the original triangle? Yes, it is. So we have rigid motion here in this example. All right, looking at C. We're dealing with the same triangle, so we still have 0, 4, 0, 0, and 2, 0. Should be a 0 there. And this one, it says that we're going to take the y-coordinate, change the sign, and make it our x-coordinate. So 0, 4, we change the sign of the y-coordinate, so that 4 is going to become negative 4, and we're going to make it our x-coordinate. And then we make our x-coordinate our y-coordinate. So my new point would be negative 4, 0. Okay, then I have 0, 0. Well, if I make that y-coordinate, which is 0, negative, we're going to flip it, and x becomes, we really just end up with the same point. And the last point, we have 2, 0. We're going to make the y negative, which is 0, negative. It's just going to be 0 as my x, and I make my x-coordinate my y-coordinate. So we end up with 0, 2. And we end up with this triangle. Do we have rigid motion? Remember, rigid motion means that I've moved the figure without changing the size or shape. Yes, we do, because all we've done is we've rotated this triangle to lay on another side. So we have rigid motion in this example. All right, let's look at D. Okay, in this example, once again, we're still using the same triangle. We got 0, 4, 2, 0, and 0, 0. The coordinates of the vertices there. What we're going to do is in this one, we are multiplying the x-coordinate times 2 and the y-coordinate times 2. So 0 times 2 is still 0, and 4 times 2 is 8. So that's my transformed point, my new location. 0, 8 is going to be right here. And then I have 0, 0. Multiply 0 times 2. I get 0, multiply 0 times 2. So that point doesn't change. And then I have 2, 0, multiply 2 times 2, which is 4, 0 times 2, which is still 0. So I get 4, 0 as my point. This is my new triangle. Does it have rigid motion? It does not, because I've changed the size of this triangle. I blew it up. It's larger. So no rigid motion in this example. Okay, we've got E here. We'll go ahead and put this down again. So we've got 0, 4, 2, 0, and 0, 0. Now in this transformation, I'm multiplying the x times 2 but leaving the y the same. So 0, 4. I multiply the 0 times 2, which is still 0, and the 4, the y, stays the same. So that is going to be 0, 4. Doesn't change anything there for that point. Let's go 0, 0. Well, I multiply the x times 2, which is 0, and the y stays the same. So that point doesn't change at all. Now we also have 2, 0. I'm going to multiply the 2 times 2, because remember, we had 2x. So 2 times 2 is 4, and the y stays the same. So we end up with 4, 0. So my new triangle is this right here, my new image. This does not have rigid motion because I have changed the shape of the triangle. Let's notice how this point was stretched out here. Actually, this point was stretched out to here. Okay, last example of these 6. This one right here. Okay, and the last one here, we've got 0, 4, 2, 0, and 0, 0. Now look at this one. The x-coordinate stays the same, but we multiply the y-coordinate times 1/2. So if I take 0, 4, remember the x-coordinate stays the same, so I still have 0 as my x-coordinate, but I multiply 4 times 1/2. Well, half of 4 is 2, so that's my new point, 0, 2. 0, 0. My x-coordinate stays the same. My y-coordinate, 0 times 1/2 is still 0, so that one doesn't change. And then 2, 0. Multiply, or x is going to stay the same. Multiply 0 times 1/2, which is still 0, so that one doesn't change. So my new triangle, the transformation looks like this. Is there rigid motion? There is not rigid motion because I have changed the shape of my triangle. I basically stretched this point down. Down to here. Okay, looking at these questions now that I have all my triangles here, the question below says, a transformation preserves distance if the distance between any 2 points of the pre-image is the same or equals the distance between the same points of the transformed image. Basically, they're saying which images have rigid motion. Which ones are the same after the transformation? Well, we said that this one had the same shape, was just moved. This one was flipped, but it maintained its shape. This one was rotated, it maintained its shape. So we have so far A, B, and C. This one was not, because it was bigger. This one was changed the shape. This one was not either. So for that question, that is our answer there. And the next one says, which transformation preserves angle measure? Now let me remind you, in the previous, where is that page? The previous page, if you look at the front page of the notes, it says, maybe it doesn't say it. If a transformation has rigid motion, then it will preserve angle measure. The angles are going to be the same just because we move the same shape somewhere else and it still maintains size and shape. It means that the angles are still going to be the same. So any of those that we had up here are going to work down here. Now I'll give you this hint as far as if D, E, or F would work for that. If I had a small square, all the angles would be 90 degrees, wouldn't they? But if I made a big square, does that change the angle measure? No, they're still 90 degrees. That means which of those three shapes that I circled can we look at and say it's the same shape, it's just larger, therefore the angles are going to still be the same. D is actually the one. Notice we have the image right here. It's the same shape as this image, just larger. So if we measured those angles, we still would have the same measure. Okay? One thing, if you're looking at your homework assignment, I would like to mention this before, because this is not really in the notes. It's just kind of something, though, that I think we need to talk about. Number 11, 12, and 13. It's talking about the transformation of triangle XYZ to triangle XYZ. Remember that apostrophe shows that that's the image. This is the pre-image. This is the transformed image. So number 11 says, what's the image of XY? Again, XY is the pre-image. So with this transformation, we still would have XY, but we would identify it by putting that apostrophe. So that would be your answer to number 11. And I'll just do number 12 with you as well. What is the transformation of Z? That's what this means right here. The transformation of Z would be Z apostrophe. That's just the new location of that point. Okay, I think that should be able to help you solve those 4 or 5 questions on that page. Yeah, and that's it.